Hello. Would there be any
Wait,
introduction? Or?
one second.
Okay.
All right, folks. Welcome to MonitoredAF. This is a monthly online event about sharing best practices and newest developments in monitoring and observability. This meetup is a joint effort of volunteers from Sydney's DevOps community. So, without further ado, So first, we'll go through some administrative stuff. So first, this meetup operates under a code of conduct. In short, it aims to be a safe and welcoming space for everyone, regardless of gender, sexual orientation, disability, physical appearance, body size, race, or religion. Thank you for helping to make this a welcoming and friendly event for all. If you have any concerns, feel free to raise them with me, Jordan, or email at the contact shown on the screen. So we also want to say that we're always looking for community speakers. If you're interested, please contact us on organizers@monitoring.sydney. So today, our special guests are Neil Miao from Cloud Solutions at Google and Graham, who is a founder at Archeum. So without further ado, let me give voice to Neil. Neil,
Hello,
you have the output.
Okay, cool. All right. Thank you everyone for having me. This will be pretty much the first time I'm actually doing this for the actual communities, because these slides are usually we run through the internal trainings actually. But it's good to be presenting some of the interesting stuff that we actually implemented and available in the GKE on-prem product. Now is actually branded as Anthos. Anthos has become the brand of pretty much everything's in GCP for hybrid. You'll be hearing that word a lot more later on. This slide will pretty much focus on showcases about how GKE on-prem's monitoring works. And I don't really have a lot of slides that actually covers how GKE on-prem itself worked, which is actually a prerequisite, a little bit of a prerequisite knowledge for it. But I'll try to cover it a little bit, just for the folks that are not very much familiar with what it is. All right, without further ado, let's move on to the first slides. Okay. Yep. I think this is pretty much the only slide we're going to talk about what GKE on-prem is. So for people that knows about Kubernetes, GCP is the one that first introduced it as a cloud solution back in 2014. And since then, the Kubernetes community exploded, literally exploded. Everybody will have it. But the GKE is still is one of the most mature and a well-oiled machine and products in the domain. And we think the experience can be extended into the on-prem environment, that people might have their own data centers and have their own existing resources and stuff that they can actually use upon and don't want to waste it. And then they can put GKE on top of it and continues the awesome GKE experience from the cloud to the on-prem, right? So that's pretty much what it is, that we can run these GKE clusters and these control planes into people's on-prem DC. But the problem is now that on cloud offering that runs the control plane for you, and you are pretty much just using your cluster and load your workloads and services on top of it. But in on-prem, you do have to run your own little admin control plane for your clusters. So you no longer just like managing your user clusters, but you're also managing the control planes that creates and manages these clusters. And that creates a bit more complexities, But it's also one of the reason we want to talk about it, because when there is a more piece moving, that we need to monitor them. Okay, let's go further on. Right, so the talk will be covering these 5 points, and we'll go through it quickly. A bit of a comparison between a on-cloud and on-prem is that for specifically the monitoring features, both of them can actually support Stackdriver monitorings. And both of them can actually use the cloud consoles to look at dashboards, and the cloud support will be actually using the ones that you exported into the Stackdriver to help you to troubleshoot things. And then, of course, both of them will be welcoming third-party monitoring solutions that you've already have your previous investment in, like Datadogs or even the open source version. As I mentioned there, Prometheus, Grafana, and the Alert Manager. Yes, and they're on demand, of course, and on GKE on cloud, that's purely is your responsibility to load them. For on-prem, we do have provide the Prometheus, Grafana, and the Alert Manager suite, the pipeline, out of the box. But they are not enabled by default. You can do it later on, and the later slides will be covering it. And the differences also lies on the matrix prefix. If you're familiar with Stackdriver, then you would know that if you watching or try to query a matrix in Stackdriver, you will be specific. The matrix will be organized into a shape of prefix and the actual name of your matrix. So for the on-cloud matrix and the on-prem matrix, they're using a different prefix. Obviously, that's on they will be used as a sort of namespaces for the metrics you can view on the Stackdriver GUI and cloud consoles. Right, so you can actually distinguish themselves on a single pane of glass of Stackdriver. I think we call them cloud monitoring now. Anyway, I'll be using Stackdriver as the name for the entire slides, but they call differently, and just bear with me. So the pipeline is different. So we will be covering this quite extensively. So this one is the Stackdriver pipeline, because if you go back to the slides, both of them will have, this one. Both of them will have the Stackdriver pipeline, and that is built in. But there are differences of the pipeline, how they look. So the GKE on cloud, will be the pieces that the Stackdriver pipelines look like in a GKE on cloud cluster, where the matrix will be primarily scrape and send out to Stackdriver monitoring from multiple different pieces. We can ignore the Stackdriver logging side. So the hipster and kubelet to GCM and the little extras, which means that they are a bunch of sidecards that can attach into the pod of some daemon sets that would like to scrape the metrics from and send them to the Stackdriver monitoring. So you will see that there were multiple lines there that goes to the Stackdriver monitoring, because these individual pieces is handling the exporting of the metrics into the Stackdriver monitoring API. The on-prem is a little different. You can see that there is only one link from the SD exporter to the Stackdriver monitoring API. Is that the metrics is centralized scraped by the Prometheus server, from various pieces, and the Prometheus server can be, you can view them as a buffering kind of layer. Although the Prometheus server have the full visibility into the metrics, but we do it this way is that we can use Prometheus server to scrape the metrics first and store them locally, and then we can have a sidecard that talks to the Prometheus server and then translates the metrics into the one that the Stackdriver monitoring API understand, and then send through it from a single component. So the data path, it's I would say slightly easier because there will be just one component is exporting the metrics. While comparing to that, it's like multiple places. If you look at the XYZ daemon, and that thing, the asterisk can be a lot of these. You may see a lot of these prompt to SD sidecard into a lot of pods, that every one of them will be sending the metrics to the monitoring API. But here, we just have one. Okay. And a bit of an architecture. Well, I think this slide will slightly help you understand the architecture of the GK on-prem as well. So I think I mentioned that is that the GK on-prem, you will have to run your own admin cluster. And then from that admin cluster, you can spawn the user cluster where your actual workload will be living. So you can consider this admin cluster just like the GKE control plan that we run in GCP, or the GKE on cloud version. Okay. And every one of these user clusters master node will be in the admin cluster, as you can see from there. And this is where the monitoring, well, that's the icon for Prometheus. We'll just simplify it, use Prometheus to represent the entire pipeline, right? So every one of these cluster will have a pipeline for monitoring the things within them. And now we can actually talk about these dual stack thing. And remember the previous slides we talked about that the GK on-prem and GKE on cloud, they both support Stackdriver pipeline. But in GKE on-prem, we support an extra open source in-cluster pipeline, which is powered by Prometheus, Grafana, and Alert Manager. And yeah, so people can opt in by disable the Stackdriver integration if they would like to, and then they can use the pipelines inside a cluster to monitor the clusters. Maybe, for example, your individual user cluster is assigned to different departments or different sub-organization inside your organization, then they have a little bit of a autonomous sort of operation mode, and every one of the team can have their own little monitoring stack. And we'll do a bit of a comparison and to see the differences between the Stackdriver stack and the in-cluster stack. So that's pretty much the differences in there. I show you these the detail of this Stackdriver stack already, but we will primarily talk about this in-cluster stack later on. Yeah, that's the one more thing that we need to mention is that for the Stackdriver stack, each of these clusters is individually monitored, and they can be viewed on the Stackdriver GUI as individual clusters. Right. We have recently created a bit of a handy little dashboard that you can actually import into the Stackdriver dashboard. Although they're in preview, but they're pretty good at showing the metrics of your clusters right now. And for more detailed information, you can go to the Matrix Explorer, and then you can build up your queries and then see more details in it. This link is at the bottom of this slide is the page for every Anthos related metrics that we support. It's a very long list. All right, let's move on to the in-cluster open source stack. We have a little interesting setup that allows a admin cluster's monitoring pipeline to be able to monitor itself and all the user clusters workload as well. We call it federation, like federation monitoring. The detail of that I'll cover it later, but just saying that the admin cluster have the ability to monitor not just itself, but the user clusters as well. And this will be a typical Grafana GUI for a admin cluster. You can see that the red squares is pointing. And the user cluster, as I mentioned, I color coded in different colors, which means that they monitor themselves, and they can be delegated to different teams. And this will be what it looks like. You will notice that the cluster dropdown is gone. Yeah. All right. So how is this monitoring pipeline powered? As now the entire industry is moving to CRDs plus operator mode, and that's pretty much all we do for this kind of feature. So all of these feature, the Kubernetes native feature will be delivered as a CRD/operator mode, which is much more easier to manage and handle and packaged. So people don't have to run their HDTDs and Helm chart anymore. So these are the CRDs and the operator that powers both of these stack. So you can see one of them, one is for monitoring, the other one's for stack driver. It was a bit of confusing because the monitoring operator is purely for the OSS stack. Right. And also we actually have the instance of CRDs for both pre-made. You can see that there is one of them is called stack driver, and the other one is called monitoring-sample. So these are the custom resources that people can tweak to make them behave differently. We'll cover that later on. So if you have both of them enabled, then you will be seeing two lots of Prometheus. This is actually a stateful set, TST. Yeah. And don't be confused about it, because they are for different stack. Right. And the monitoring operator location, they are, as you can see, they're all located in the admin cluster. So these user cluster will have their control plane, aka the master, in the admin cluster where the monitoring operator will be in. And this one is actually for the admin cluster itself. And this operator will be the one that's responsible for spin out, well, to create, change, update, whatever that the monitoring stack in the individual user clusters. And because the operator is actually manages, well, they take the CRD you defined and also we defined, and then converted the CRD into a series of parts and services and config maps and blah, 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 blah. And there was also have a side effect is that for all the resources that manages by the CRD/operator, they are sort of reconciled, which means if you change it, then it will get reverted. So sometimes if you want to do some hackings to tweak the actual monitoring stack that to what you really want, and you notice your change doesn't stick, and that will be the reason. All right, there are a bit of a details about what this customer resources look like. Custom resources, sorry. This is for the stack driver operator, and you can see that the type is called stack driver. And this stack driver is the actual name of the resources. So it looks weird, like you get stack driver, but one of them is a type, the other one is the actual name of the object. And these other stuff is actually pre-populated when you install the GK on-prem cluster. And yep, keep going. And remember that we talked about that the stack driver exporter in GK on-prem is the only one that exports the metrics to the stack driver monitoring API. So that stack driver exporter is actually a thing called stack driver Prometheus sidecard that lives inside this pod called stack driver Prometheus-KAS-0. So the sidecard is the one that will fetch the time series and from the Prometheus, and then convert it into the API calls to the stack driver. So this will be the one that responsible for writing your metrics into the stack driver monitoring. And if you can't see any metrics, or if you see any gaps on the metrics that you saw on the stack driver GUI, then this will be the one you need to check. Right. I think this one is a little duplicated. This should be fine. Anyway. All right. So now the in-cluster monitoring stack is not enabled by default, which means you do have to patch it to turn it on, which is pretty much simply just change that little custom resource and enable Prometheus. And once you do that, all these will show up. And this will be a supported way to allow you to view the Prometheus GUI, which is from where was it? From the stateful set of Prometheus, right? And you can do the port forwarding and to the actual pod, and you can test out the metrics and see if they're there. And yep, and similar things to the Grafana. Yeah. Now there is an interesting bit. It's like we pre-make this Prometheus, Grafana, and Alert Manager pipeline for you. Is because we would like this whole open source pipeline is secure and protected. So that we would like to not allowing the other people, other pod will be able to just scrape or look at your metrics that are exposed from the Prometheus and Grafana. So the entire monitoring pipeline, even though they're open source, we add some security bits into it, so that only the allowed components or allowed pods in your cluster will be able to reach these monitoring endpoints, right? And this is the reason that this is the requirement, or the reason that we would like to do that, right? And how we do it is we stick a RBAC proxy sidecard to your monitoring pipeline, every one of the pod. The scraping actions or scraping verb, HTTP GET or whatever, will have to be going through this RBAC proxy sidecard. And ultimately, then that can be rich to the actual monitoring endpoints, such as Prometheus or Grafana. And the RBAC proxy will be the one that allow or deny such access. And of course, the cluster admin can debug it through the port forwarding, as we saw, and also that they can actually go into the actual machine and run this, pretty much start a debugging container in the networking namespaces of the monitoring pod, for example, and then they can access the monitoring pipelines, or sorry, the monitoring endpoints from there. But that's only the cluster admin can do. So it's not that. So the attack surfaces will be shrink to only the people that can do this to be able to reach the monitoring endpoints. All right. So the target discovery is as is Prometheus. So we heavily use Prometheus. So the Prometheus have a very nice little built-in target discovery for Kubernetes. So we're using that, right? It's a thing called Kubernetes SD config, and then you will see that a bunch of config maps. One of them is called Prometheus-config, which is one of them. One of the resources managed by the operator, and we actually provide is in the box that the Prometheus is configured to scrape the various places to get the metrics. And you can actually, this is some of the details about how Prometheus keep metrics from a specific pod. So this one is a example of a Prometheus jobs. It will get a metrics from all the pods, but it will keep only the metrics from a pod that have a label of KAS_app equals the manager. So this is some Prometheus specific stuff, isn't it? But if for people that are savvy with Prometheus, they should know this already. Yep. So that specific, sorry, let's go back. That specific Kubernetes SD config is the one that automatically discover what they can scrape from the Kubernetes API. And yeah, and then the Prometheus will scrape them accordingly. And the stack driver add-on I can show is the sidecard will be the one that scrapes or get the metrics out of the Prometheus and then send it out. So these are some of the annotations that our built-in job, Prometheus job, is configured. So the Prometheus will scrape 3 types of resources. So the first one will be the hard-coded labels. That's for the control planes. And then the next part will be the whatever pods or services is actually annotated with monitoring.gke.io that they will be scraped. And the third one is that in the user cluster, people can manually annotate their workload or services that with the Prometheus.io. And then that will enable the built-in open sourced in-cluster stack to scrape them. This behavior is pretty much the same as the open source Prometheus server. Anyway, right, these are some of the jobs that is pre-made into each and every one of these cluster stacks. So this is for the stack driver stack in admin cluster, stack driver stack for user clusters, and the in-cluster admin cluster, and the in-cluster user cluster. So for this one, you can actually see that the Prometheus-IO annotation only works in the user cluster, which is why, sorry. And the reason for that is that only the one in them will be scraping the resources that with those annotation squared now. All right, so there's some general rule of thumbs when to look into the matrix. That's for your troubleshooting. That's pretty obvious. Now, this interesting multi-cluster federation monitoring that I talked about. All right, I'll go through a little bit. So you can see that each one of these clusters will have these pipelines in there. Sorry, I do have to mention that this federation monitoring things only apply to the in-cluster open source stack. They have nothing to do with this stack driver stack in the on-prem setup. Right, so you can see that we have to introduce something called push proxy to work around the fact that these admin cluster and the user cluster might not be even in the same routable network. So they will be the one that actually facilitates the federation monitoring, which because that for the federation to work, the Prometheus in the admin cluster will need to be able to scrape the workload in a user cluster. And the way we do it is that the Prometheus, the way we do it is that the user cluster will be actually advertising themselves to the admin cluster into this push prox server component. That's a pod actually. Basically, the user cluster 1, a user cluster 2, they will be announcing themselves into the push prox server, saying that I am available here. You can scrape me. And then the Prometheus server, sorry, the Prometheus pod in the admin cluster, they will be able to discover all of these resources in the user cluster through their control plane, and then the scraping request for a specific workload in the user cluster will be actually directed to the push prox server. And the push prox server will be the one that's responsible to pass that specific scraping request to the corresponding push prox client in that specific user cluster. And the path will be look like that. So the push prox clients will push to the push prox server saying that I can scrape something because I know how to scrape them. And then whenever the Prometheus pod in the admin cluster will try to scrape something that is not in this admin cluster, it will go to this push prox server. And then because the push prox server already knows who can do that scraping, so that request would pass on into the specific push prox client, and then subsequently the metrics can be scraped from whatever the Prometheus instances in the user cluster. It's an interesting setup. It's complicated, and I draw out this actual data path for how this federation monitoring works. And I can't really go into too much details in that because it involves a bit of a trickeries in RBAC proxy to direct the scraping and the push and the pull actions. I think the slide can be shared later on. I'll stop here. All right, this is the last slide. Done. Over to you, Adam.
All right, 1 second. Let me ask you some questions that we have from our audience.
Sure.
So, first is, can we ship to Stackdriver using OSS tools like and OSS standards like OpenTelemetry or OpenTracing? Do you know by any chance?
Open tracing, the Stackdriver tracing is actually baked into the Stackdriver pipeline. In the, if we go back to very early on, sorry, just hold on. Okay. So the OpenTelemetry tracing stuff is done through here. If you would like to use the open source stack that we shipped to do to send traffic to send metrics to Stackdriver, that will be a little bit of a redundant because the Stackdriver pipeline is already there.
All right, fantastic. So the second question we have from our audience is, what kind of latency do we see on metrics pushed from on-prem containers to Stackdriver? Are there like in the ballpark of seconds, minutes?
The latency, what do you mean by latency? Every one of the requests to the Stackdriver?
More how late will we see those metrics in Stackdriver? So for example, if you set up an alert, will the metrics arrival to Stackdriver be delayed by processing or by the or is it only like the client latency we need to worry about?
Right. I don't have a specific answer, but we do have a public doc to tell us how frequent is the metrics being scraped. Also, there will be another layers on the Prometheus, is that how frequent is the Prometheus scraping your metrics? That will be the first one that you need to think about. And then the actual latencies between, I don't have a specific answer for that. Wait, they might have to look into the public doc. I can't remember them.
Yeah, no worries at all. We can always just put it later in the comments. So, yep. Additional question is, are there any cardinality limitations with shipping metrics to Stackdriver? So can people use high cardinality dimensions like deployment IDs, feature flags, user IDs, etc.?
The type of the metrics is actually a bit of a fix. So if you look at the source code of the Stackdriver Prometheus sidecard, there was a list of how we do the metrics translation from the Prometheus metrics to the Stackdriver metrics. And not all of the schemas is actually supported. So for your metrics, you do have to fit into some of the types, like for example, KAS container, or KAS underscore node, or KAS underscore pod. And for some other, or I remember there is a general one, it's like there is a specific job type in there. So the high cardinality metrics, they would have to be translate to fit, to fit into the schema that we support.
Understood. You mentioned source code. Is that source code public?
That's open source. That's open source.
Fantastic. In this case, I'll.
Yeah.
Oh, sorry.
Yeah. You can find them in GitHub.
Yeah, we'll later publish a link in the comments. So, and I think one last question from us, which is kind of like a more simple one, is do you have any idea if Stackdriver will ever get dark mode?
Dark mode? I don't know. I'll find out.
Fair enough. All right. With that, Neil, thank you so much for your presentation. We really, really appreciate it. And let me get Graham to set up.
Let me stop present. All right, cool. Thank you.
Yeah, thank you very much. All right, then let me give Graham a second to set up. All right, so in this case, just give me a second. All right, audio and visual is here, so let's do it.
So I'm going to be talking about mapping evolutionary microservices today. And I want to start with two bits of news, two bits of bad news. The first is that a lot of people will say now that we don't understand the software systems we're building and operating. Obviously, that's a pretty big problem if we're building things but don't understand them. And the second bit of bad news is that monitoring is not the answer, or at least it's not the whole answer. So who is this bearer of bad news? My name's Graham Lee and I'm the founder of Archium. I'm known for being generous with my opinions on microservices, of which I have many. And I was previously at Tyro Payments from the time that they were about 30 people until a couple of months before they listed on the ASX last year. I did a bunch of different things there. So what are we going to learn about as I talk? Hopefully you'll learn a bit about microservices, why you might do them, and specifically what they are. There's lots of different views out there about what microservices is, so I'll give you my opinions and tell you where I've sourced them from. I'll share some architecture design tips, talk a bit about how to understand microservices systems, and then I'll give a little demo of Archium and hopefully show you how that can help with understanding systems. So I was going to start with what does microservices mean? But then I thought that's actually a really bad place to start because microservices is a solution. So if we want to talk about a solution, it's really best to start with the problem. So let's start with why. Why consider microservices? And the way I like to summarize this for people is that microservices architecture is primarily about solving organizational problems, usually in businesses that are scaling. So while the idea of implementing microservices is quite technical, we're talking about software, talking about how we're going to cut it up, talking about how we're going to ship it, change it, test it. The actual things we're trying to solve with that technical solution are organizational problems. And so it's important to understand what those problems are because microservices comes with a pretty high price tag. It's not cheap to cut one piece of software into 20 bits of software, ship that all to a network where things are communicating and be able to manage that. It's not cheap at all. So we want to make sure that if we're going to spend this money on developing microservices, that we are actually going to get some return on that investment. So some examples of problems that microservices can help solve. You might have multiple teams working on the same code and they're getting lots of conflicts and that's slowing down the development. You might have really long build times because all your code is in one piece of software and it just takes ages to build it, and so people waste a lot of time waiting for that to build. You might have cross-team coordination for deployment. So before you can ship something, everyone needs to agree we're going to, do a code freeze. We're going to ship on this date, and that's going to slow things down, obviously. You might have lengthy or risky deployments. So maybe a deployment, actually takes a whole day for a couple of people to do, or maybe, need to put a lot of protection around it in preparation. Or maybe you've got a legacy tech stack for your monolith, and that's slowing down your development, and you can see that people using other tools are going a lot faster. So I hope you can see that most of these, while they have a technical aspect to them, a lot of them about how the organization's designed, how people in the organization are interacting. And so they're the kind of things microservices can help with by dividing up those things so people can focus on different areas. But we want to remember the costs. So quickly, some of the costs that microservices will add when you go down this road. You're going to end up with a lot more formality around integration. So instead of integration being a method call between two things, you now have some kind of schema or contract between two services, and you'll need to agree that between teams by talking about it, sharing documents, that kind of thing. You're going to have a lot more continuous delivery pipelines if you've got lots more software, so that's going to incur a time cost. You're probably going to want to do some backwards compatibility design and testing. Once you're able to upgrade one piece of software without upgrading the rest, you want to make sure that when you do that, it's not going to break everything. You're going to have an increased security attack service once you make more and more of your functionality available to the network. So that's going to have a cost in terms of ensuring all of that is secure. Of course, monitoring is going to become more complex once you have many things to monitor more rather than one. And just comprehending the complexity of a system can become more difficult. One really simple example of this is if all your code's in a monolith and a component's talking to another, you can control click on a method and you'll see where the code goes and what it does. Once you're chucking things into different bits of software that are open in different project windows and don't talk through method calls, they talk through JSON, surfing around your system and understanding what it's doing and how it's interacting becomes a lot more complex. So if you haven't gone to microservices or you're just about to, you might be thinking, should we do it? And there's no obvious answer to this. But the way I try to help people who ask me about this is to point to some heuristics. And all the heuristics that I talk about are on a spectrum. And I like to think of that spectrum as, on the one hand, there's one side of the spectrum has a small return on investment for using microservices. And on the other, you have a higher return on investment. And so these are the main ones. So, for example, if you have a single team, and by team I mean probably 15 or less people. If you've got a single team working on your software, then you're probably not going to have heaps of ROI from implementing microservices because it's very unlikely you'll have organizational problems in a team that small. On the other end of the scale, if you've got 5 or more teams, then you're starting to see that there's going to be a real return for splitting up your system in a way that lets each team focus on different bits. Again, if you have a single product in your business, you'll get less value than if you have multiple products that are integrated with each other. If your business is still in a discovery phase, then that might limit your ROI because you might end up wanting to change lots of things as the first few years go on through the business. And when you have things split into microservices, change becomes quite hard. Whereas on the other end, if you have a mature business or you really understand the domain of your business quite well, that's going to make the path to good microservices quite easy. And then lastly, if you've got a pretty simple domain, then it might actually be quite easy to fit it all in one bit of software. Microservices will give you a better return when you've got a complex domain or possibly many domains. Now I understand why you might want to do microservices. Let's have a look at what it means. And it should be simple, right? Because the word just means really small services, right? Which is funny because we can say, well, how small is really small? And really, we should even be saying, what's a service? And ultimately, the name microservice is one of the really good examples of how naming things is hard because the people who named this, they were thinking these services are small, but they didn't really want to emphasize the smallness. In fact, the size of a service in microservices is one of the least important aspects when you look at the pioneers of this method and how they say to go about it. So in understanding what it does means, I like to look to the experts. I've got quite a lot of content about this, but I've just tried to cut it down to give a bit of a quicker overview. So I'll just look at one person, which is Sam Newman, who literally wrote the book on microservices. Sam was a consultant at ThoughtWorks, where the idea of microservices first started and developed quite richly. And then he went and wrote a book about what they've been doing. So he says microservices is an approach to distributed systems that promotes the use of finely grained services with their own life cycle, which collaborate together. And when he talks about having their own life cycle there, he's primarily talking about the ability to shut them down and deploy them independently of what else is going on in the system. He goes on to give a few dot points about services, such as they're primarily modeled around business domains, they're small and focused on doing one thing well, and they're autonomous. And when he talks about autonomous services, he's kind of talking about a service being responsible for achieving its own tasks and trying as much as possible to complete its work without relying too much on the other services around it. So yes, microservices is about things talking to each other, but we also need to think that in order to get autonomy, they need to collaborate, but also not collaborate too much. Sam gives this golden rule about microservices. He says, can you make a change to a service and deploy it by itself without changing anything else? He says that is the key to microservice, and I think the key to the value as well is being able to develop different bits of software at different speeds and push them to the customer. So let's look a little bit at how you go about designing services. And I want to give a really brief overview of this practice called domain-driven design, because when you read through the early microservices descriptions, you can see that this has had quite an influence on the way they're thinking about things. And so I summarize domain-driven design as being two activities primarily. The first one is to foster really close collaboration between domain experts, that's people who know about how the business runs, and technical experts, it's people who know how to build and deliver software. And those two groups are going to together iteratively refine an abstract model of the domain. So they're going to decide, they're going to talk about what the domain is, and they're going to start documenting it in an abstract model. And they want to continue iterating that and make it more and more accurate. And as that's being done, the abstract model of the domain becomes the basis for the technical implementation. So if you were to look at this abstract model of the domain, which isn't about software, it's just about describing how a business works. And then you looked at the software that implements or automates part of that business, you should be able to see very close correlation between the model of the domain and the model of the software. Domain-driven design also has this nice idea of a ubiquitous language that pervades the model and the software. And so the key there is that within describing the domain of a business, there will be lots of terms that have a very specific meaning, and it's very important for the team to agree on what those meanings are and write them down, and then use that language everywhere. So for example, if you're in banking and you have a term in your abstract model called a loan, you'd have a definition of what a loan means. And then in software, you would use the word loan wherever you mean that same thing that you meant in the model. But if you have something else that's not the exact same meaning, but you think is a loan, you need to find another word, because that word needs to be ubiquitous in its definition across those two zones. Just one more thing about domain-driven design is that domains will have subdomains, so subdomains will have subdomains, and subdomains have their own model. So if we go back to banking, we can think a bank or banking is a domain, but within banking you've got transaction accounts and lending, and maybe you've got share sales as well. So they're all subdomains. Then within those subdomains, you'll also have subdomains. So a transaction account will have transactions and payments and interest and a bunch of other things. And within each of those subdomains, you have their own little models. So you don't just model the whole domain as one giant thing. You section off those models into the subdomains. And that leads on to a term called bounded contexts, which is about those models being mostly bound within that subdomain and not leaking into the models around them. So one of the biggest questions about microservices is how big should they be? And there's lots of opinions going on around this. And the thing I like to think about mostly, weighing most heavily on this, is that they're primarily modeled around business domains. But this has to be in balance with those two other dot points that Sam was making. So while they're primarily modeled around business subdomains, because if you just did your whole domain of your business, that would be a monolith, they're also focused on one thing, and they're also autonomous. And these things can kind of play off each other. So the problem is, if you go too small, if you start cutting up things really small into really small services, then those services won't actually encapsulate a subdomain. Instead, to find a subdomain, you'll need to look at a conglomerate of services and how they interact together. And you'll also end up with minimal service autonomy. The more you slice services up, the more they need to talk to other services in order to get their job done. And at that point, we're ending up with services that can't really run on their own. They need to be part of a bigger thing in order to get stuff done. On the other hand, if we go too big, obviously we're not going to end up solving those organizational problems. If we only cut, if we've got 20 teams and we cut our software into 4 services, then we're still going to have an average of 5 teams stepping on each other's toes in each of those bits of software. My observation is that the tendency across industry seems to be for people to go too small. And so I would say, let's try and do the other way and go oversize. And I think in general, the pain of an oversized service, once you get away from monoliths, the pain of an oversized service is a lot less than the pain of a group of undersized services. In particular, understanding an oversized service will be easier than understanding a group of undersized services. And also refactoring inside an oversized service, if you find you need to do that, will be much less pain than refactoring things which are in different bits of software and trying to talk over the network. So in terms of that balance, I would say weigh heavily on modeling around domains and keeping things autonomous. And this idea of doing one thing, I mean, you want to keep your services simple, but at the same time, I think do one thing is a bit strict. I would more say, think about doing one subdomain. Now, some people really want to focus on the micro in the name microservices, and I suggest just chucking that in the bin, because when you're doing that, that's a really technical focus. Let's make the piece of software as small as possible. That's a bit of a technical thing, and it's kind of moving away from this idea of solving organizational problems. Some signs that you may have gone too micro, and I'm going to caveat this with strong opinions, loosely held. Everything's contextual, so there can be really good reasons to do these things, and maybe some people can make them work really well. But to me, they look quite dangerous. So one is, you might have heard, ideally services are as small as 100 lines of code. And when I hear that, I think you're probably going to struggle to express a whole business domain in 100 lines of code. That seems quite challenging. You might hear you should be able to rewrite a service in 1 week. And again, similar thing, I'd say it would be a very simple domain where the whole model and all of the logic related to that domain could be written and tested in 1 week. That seems like quite a stretch. And another thing I see is people saying, oh, our team of 500 developers manages over 1,000 microservices. We've got, more than 2 microservices per person. And when I hear that, I think your business probably doesn't have 2 subdomains for every developer. You can't cut your business down so small that every developer has 2 parts of the business that they focus on. And so I think maybe that's going too far. My opinion on sizing is that if you have a team of 8 to 10 people, then they will be caring for between 1 and 4 services. And the reason for that is that you want a team to be able to focus on 1 or maybe 2 subdomains. Part of the whole point of microservices is letting a team become an expert in a subdomain and manage the software around that subdomain. Now, they may split those subdomains further, which is why, having 1 to 4 is where I think is a good fit. Now, I don't want to say you should never split things because of technical reasons. There's going to be places all over the place where you will want to look at some software and say, okay, even though this is 1 subdomain, we need to split it. One good example of that we did all the time at Tyro was the idea of a web DMZ. Because of some of the regulatory requirements on us, it was absolutely forbidden to have anything facing the internet, which could also connect to a database. So just by that definition, every domain that ended up being customer facing had to be split across at least 2 bits of software. So we had a web app and a service, and they would talk to each other. So that's one example. There will be other examples of where you will split things for technical reasons. But the key point is that should be your last consideration. The first consideration is, how do we split our software into subdomains of the business so that teams can focus on them? Another thing about designing services I'd just like to quickly cover is a thing called macro architecture versus micro architecture. And I first heard of this from a consultant called Stefan Tilkov at InnoQ in Europe. And so he draws this distinction between micro architecture, which are the decisions that you make inside a service. So here he's got an example of what is the language in which the software is written inside a service. And the key thing about these decisions is that the details shouldn't affect others too much. You need to architect the system, so that's true. So obviously, if you've chosen Java, you don't want to then expose an RMI interface because you're going to force Java on other people. But that's the idea there. And then he contrasts that with macro architecture. So macro architecture are decisions that are extra service. They're outside the services. They're between the services. And they're typically details that could affect everyone. So some candidates for what could be in macro architecture is the interprocess protocols, the messaging infrastructure you're going to use, the monitoring that you're going to use across the whole system, your deployment methods for getting software into production, and your authentication and authorization mechanisms. Now, I say candidates because Stefan really stresses that There is no prescriptive list of what is macro architecture and is microarchitecture. Instead, there's this menu of all these choices, and within your organization, you want to decide which things you're going to make macro and which things you're going to make micro. When you make things micro, you give teams more autonomy, and that can be good. But giving teams autonomy over some things could end up being bad for the wider organization. So what he really encourages is having a frank discussion about what do teams get to choose for themselves and what is chosen at the organization level, because that will enable productivity at the organization level. I want to touch quickly on the concept of evolutionary architecture, because I dropped the word evolutionary in the title. I thought I should explain it. Importantly, it's not just emergent architecture. It's not the idea that we'll just start coding and some kind of architecture will magically appear and hopefully it's good. Instead, it's very well documented ideas from this book, Building Evolutionary Architectures, by a bunch of people at ThoughtWorks. And their definition is that it supports guided incremental change across multiple dimensions. There's quite a lot of ideas packed into that, but I boil it down to 3 actions, and they are this. First, you choose the most important architectural qualities, the things that's most important for your system to achieve. So some examples would be security, or maybe audibility, or maybe performance. Could be any of these things, could be all of them. But you need to decide what they are. And then you're going to define unambiguously how you're going to measure these things. So we're not talking about let's do a survey once every 6 months to decide do people think our system is secure. Actually going to have ways that you will already have defined before you build the system. We're going to measure security in this way, and it will give us a definite pass or fail. Then the third step is change production a lot. Go ahead, change it as much as you can, get value to people as quick as possible, but measure those architectural qualities continuously so that you know as you're making changes that you aren't making the system worse. So boiling that down into one sentence, the way I would word it is evolutionary architecture is about deliberately designing for rapid change that's demonstrably non-detrimental. So we're going to change our system very fast, but we can prove that we haven't made it worse as we push those changes in. Just going to have a drink, excuse me. So now I want to talk about understanding a microservices architecture. And I feel there's 2 facets to this. The first one is understanding the running system, which is very important. And there's also understanding the system design, which is important for changing that design as time goes on. So let's talk about understanding the running system first. And hopefully you've realized this is really the purpose of monitoring. Monitoring is so that we can look at our running system and we can understand what's going on. So we've got our metrics, our traces, our logs, and our alerts. And I have a look at each of those quickly and how microservices affects those things. So metrics is all about quantitative measures of our system health. We want to be pinging our system about things, getting it to tell us information, and we're going to decide from that information, is our system healthy or not? And we'll do that at a bunch of different levels. Do it at the infrastructure level, do it at the application level. Some places we'll do it at the business level, which I really like. So, are we making revenue today? That's a good thing to measure. And you can take it even further. You can actually say we want to have metrics around quality. How much quality is in our system or our software? And as evolutionary architecture was talking about, how can we measure the fitness of our architecture? Now, microservices makes metrics harder. Obviously, there's more things to monitor. That's just straight away harder. There's also more variety of things. This isn't like when we have a monolith and we decide we want to go from having 2 instances to 70. We're actually providing a whole bunch of different things that we now need to monitor. It might even be in different languages or in different types of hardware. Also, normal becomes very contextual because there's a variety of things. What might look like a problem in one place might actually be normal for that place, whereas compared to another place, that might be a problem. And also you'll end up with some team specialization. As teams are focused on different parts of the domain, they'll want to get monitoring about different parts of the system. Now, alerts, when I think of alerts, I think about requests for attention to anomalies. So metrics tell us what's happening. Alerts should tell us when what's happening is not normal. And alerts are harder for all the reasons that metrics are harder. In particular, this idea that normal is no longer contextual. We can't just chuck an alert on a certain amount of memory for everything in our system. Teams are going to have to understand their individual parts of the software better. They're going to need to be tuning those alerts to their special needs. When I think of traces, I think about pinpointing performance and error causes. So before microservices, we had this thing called APM, which would measure performance. And if we zoomed in here on an APM system, what we'd see is method calls between bits of code. We'd be measuring the time spent in each of these methods. When we go to a distributed system, we're not so much interested in the internals of software. We have distributed tracing. And when we zoom in on that, what we see is individual services that are talking to each other. So we're looking at how much time is spent in each service. And we can also measure how much time we're spending going out to other remote things as well. Of course, microservices makes tracing harder. Key reason there is because we need to pass this context. If we want to report off to something that all of these services spent some time handling a request, then they each need to be able to identify that request uniquely and report to some other party that they spent some time on that particular request. So that needs to be passed around as messages move from system to system. And if we've got polyglot software, then that's going to complicate things as well, because we need to choose a tracing solution that is going to support all the languages and all the frameworks that we're going to be using. It's really important because with tracing, if you miss a link in the chain, if you can't put tracing somewhere in the middle of the stack, you're actually going to lose your tracing at that point. And even though things beneath it might have tracing, they won't be able to connect it to the things further up the stack. The other thing about microservices is often the infrastructure becomes more interesting. So if you just had a load balancer in front of a monolith, you'd probably put some metrics on that, but that might be all you do. Whereas if you're using a service mesh and you've now got proxies and sidecars and all kinds of things like this in your architecture as well, there's more of a chance that you're going to want to be putting some monitoring on them and be able to trace the time that is going through those things. Lastly, logs, I think of as detailed reports of internal activity. When I think about logs, I think when our metrics or alerts or traces point us to look more closely at some service, how do we tell what's going on inside it? And that's the question that logs are meant to answer for us. So, of course, again, microservices makes logging harder. Just like the tracing, we now want to have some correlation. So we don't want to go to each service and have to find a new way to find the logs associated with a particular request. We want all logs to be able to report some ID, which you can search and then get all the logs for a particular request all in one go. If we've got a polyglot system, we want to probably think about how we're going to have logging that has uniform formatting in case we want to do some kind of post-processing. And also, we're typically going to end up with a lot more volume of logging when you move to microservices. So some of these monitoring challenges show why macro architecture is a really good way to add governance. Bit of a big business word, governance, but even if you're a small business doing microservices, you're going to want to put some governance in place. And you've got to think, if we leave every team to implement monitoring in their own bubble, what we're going to end up is a really unusable mess. If that team does tracing this way and another team does tracing another way, that's not tracing. That's just some logs, basically, that aren't connected, and we don't get a trace. So I'll move on now to talking about understanding the system design. And just thinking about monitoring lastly, it really helps us answer questions like, is the system healthy? Are there anomalies occurring? What are the performance bottlenecks? What's going on inside the software? But there's questions that monitoring struggles with. Some examples of that are, what's the full API of this service? What types of messages does a service receive and send? What's the architectural neighborhood around a service? What features of the system is a service involved in? Which features have temporal coupling on which services? And what are the potential failure modes of my system? Important thing to know. Now, some tracing tools are using the data they have to provide views that will help with some of these questions. In particular, you'll see dependency diagrams in most tracing tools. And you'll get you get different levels of quality in these. So some are quite helpful. Some of them seem like their main purpose is to make you feel more confused about your system and run away. But some of them are more organized and have quite a good look. The thing I found as I've looked through some of these is that I often find these tools are really focused on understanding the running system. Even though they're showing an architecture diagram, they'll often be pulling into it some real-time telemetry or trying to tell you where errors are happening or where slowness is happening, that kind of thing. And their primary use case is almost always coming from the idea of incident response. People come to these tools to handle an incident. And so even when we're showing a bigger picture view of the architecture, that's the information that's going to be focused on. But I think if our goal is to understand the system's design, then we're probably going to collect different information and we're going to present it differently. So we can't rely purely on information that's come from a performance measuring tool in order to understand our system's design. Now, there's lots of common patterns popping up around microservices in terms of understanding system design and communicating the system design. Architecture diagrams are an obvious one, and there's a few different flavors of doing that. Some people will still be just drawing them by hand on a wiki. There's a lot of people now doing this nice idea of having a textual language for describing the system, and then having diagrams automatically generated for them and put into their source control. Then you have the idea of service catalogs. That is the idea of listing out all your services and then keeping some information about each service handy so that people who need to find something out about a service quickly can go and find it. Lots of people have the idea of a design one-pager, or sometimes they'll let it go more than one page if it's really complex. So that's the idea that we try and succinctly describe a service and put that somewhere that people can find so that when someone suddenly needs to understand how something's built, they can go and find it. Architecture decision records, or we could say macro architecture decision records. So they're about just writing down what decisions have been made and why they were made. And runbooks too are also a way that we can understand the way the system is designed. And so the product Archium that I have is playing right into this space, the idea that we should be able to understand our systems design. And that is the goal of Archium, is to help teams understand the systems design better. So we want accurate diagrams of our system. Humans work really well with looking at pictures. And we also want detailed information about our services. But the challenge that microservices bring is that our system is now constantly evolving. It's changing probably every week, the structure of it. And if we're trying to document that manually in a wiki with templates, no matter what we put in place, most organizations I've talked to, they have a losing battle with this. They want to have good understanding and be able to communicate information, but they're having trouble keeping up. And so really, we need to automate. As this is moving so fast, we need to automate as much of it as we can. And so what we're doing with Archium is we're leveraging the tracing data in order to help the understanding of the system's design. So we start with that data in the distributed tracing tools, which is performance telemetry, and then export that performance telemetry and convert it, and in fact condense it until what we've got is a model of the architecture. And then that model of the architecture can be loaded into the Archium self-hosted web app. And then people can basically go into that web app and browse around their architecture. So it looks a little bit like a service dependency diagram, but it actually is different. Of course, it's got some more details. So I'll give you a little demo of it now so that you can see how it adds a different slant on the idea. So first we'll just think about this use case of having a new developer join a team. And they're going to join the royalties team. And they're going to be asked to go into Archium and learn about the architecture. So how quickly can they learn about the parts of their team's architecture? So I'm just going to change which window I'm sharing here. If you'll wait with me a couple of seconds. Okay, here we go. So this is what someone will see when they jump into Archium for the first time. So you can see straight away we've got this components directory, and our components are split into two categories. We've got services here, and we've got a bunch of databases as well. And we've also got this flows directory here, and if we have a look at some of them, you'll see they've got names like add artist and create account. So obviously these are use cases that happen in our system. Now, this developer's joined the royalties team, and just scanning through the list, we can see there's something called royalties, so it makes sense. Let's click on that and just see what happens. And we'll get this pane of information out about the royalties component. And there's a bunch of details there. There's also this attractive button up here for focusing the map. So we'll focus the map on royalties, and we'll get this pretty picture here. And we can see royalties is here right in the middle of the picture. And we've got a legend here that'll help us understand what we're looking at a bit better. See our blue things are components, and we've colored databases in gray to kind of make them stand out a bit. Then we've got two types of messages. Blue solid ones are synchronous messages, and green dashed ones are asynchronous messages. And these labels on the arrows show us the name of the entry point at which a service message is being received. So having understood what's going on there, we can zoom in here and kind of see a bit more about what's going on. So we've kind of got two branches coming into royalties here. We've got from this web app and this mobile app up here, we've got some REST requests coming down into this content streaming component. And then we can see that it chucks something onto a Kafka topic called user audio plays, and that's how that has a connection down into the royalties component. On the other hand, up here, we've got this publisher's web app where it's calling on the web server some get royalties path. And that's ending up down through this royalty payments reporting component here that's then making a REST call into royalties. So we can see there are two different types of flows, and we can see if we look beneath royalties, it's got a database and it talks to this royalty payments thing that also has a database. Now, if we look at this extra information we've got over here, we can see royalties to service has 4 entry points. It's got 2 Kafka queues, it's got a REST endpoint that it exposes, and it's got an SQS queue as well. It has one trigger event. A trigger event is something that happens internally to trigger off a flow. So we know there's flows that are starting up at these components, but royalties also has an internal thing, like a cron job probably. And then we have these supported flows, and this is where some of the magic vacuum starts to happen. So here are the flows in the system that this service supports. So we can see this mobile app and this web app, which we saw over here. They each have a flow called play song, and that is ending up at the royalty service. And this little icon here, this green thing, it's actually telling us that somewhere between where this flow started and where we ended up hitting the royalty service, there was an asynchronous message passing. And what that means is that this flow is temporarily decoupled from this service. So if the royalty service isn't available, these play song flows will still be able to complete successfully, and royalties will pick up the information later on. Conversely, looking at the publisher's web app, which is this one we saw up here, we've got the review royalty reports flow up there, and we can see that with this little chain link here that's telling us that the start of this flow down to this service is synchronous all the way. So it's synchronous all down there. We saw that. There's all blue lines. And so if royalties to service is unavailable, then this report is probably not going to be able to run. Now let's have a look at this pay royalties flow, which is the one that's triggered off inside this component. And we can now, instead of looking at the map of the component, we can look at a map just of the flow. So now instead of seeing everything that flows into royalties and flows out, we're seeing that the message is just related to this single use case. And we can see that it uses particular things on the database. It does selects and updates. It's not inserting stuff. That's obviously happening in some other flow. It's got the SQS queue that it both writes to and reads from. So it seems like it's building some work queue for itself there. Then it's passing some information to Kafka, which has this SQL work queue pattern again. It's doing some inserts and updates to its database, and it's using this Adyen SDK to do a credit. If we wanted to, we can surf around other things that are royalties. We can click on things in the map and bring up information. We can center the map on different components. We'll get a slightly different view each time, depending on the things that a component is involved in. But you can see that pretty quickly we've been able to get a good idea of all the things that this royalties team takes care of. So just give me 1 second, and we'll just flick back to have a look at another use case quickly. So our next one is, let's think about, we've had an incident, and that incident has impacted new user activations, which is what a lot of growth teams want to focus on. Can new users get in the system and do their first action? Because we know when they do that, we get revenue a week later. So we've had a problem with that. So now we've got some reliability concerns, and we want to figure out which services in our system are most critical for getting these new user activations. And so we'll flip back to Archeum and see if we can figure that out. Now, if I was going to do this at my previous job, if someone came to me and asked me this question, I would probably get a whole bunch of tech leads into a room and spend hours trying to draw diagrams, maybe look at some code and figure out what the answer was. But with Archeum, most of the information we need is pretty readily available. So I happen to know that everything to do with this comes through the web app. So let's load up the web app component. And again, we've got all supported flows here of the web app. Now, I know that the first thing someone's going to do if they're a new user is create an account. This is just a typical web app, so I can control click on here. And I'm going to end up with a new tab up here that's going to have that flow in it. After they create an account, then they're going to log in, and they're going to see the home screen, then they're going to do a search. And in our system, after they search, they've got to look at an artist. And once they've looked at an artist, then they can play a song, which is where the growth team really wants to get people to quickly. And so we want to understand what systems are critical for all of these flows to complete successfully, because we're gonna do some efforts on making those parts of our system more reliable and more resilient. So we can look at the map here if we want to, but we don't really have to, because this dependencies list tells us everything we know. There's 5 dependencies, 5 entry points. We've got 4 components here. And we can see here our little green symbol tells us that security logs down here. While it's used in this flow, it's used by an asynchronous message. And so it's not dependent for the flow to complete successfully. So I'm trying to build a list. Yeah, no worries. How are we going?
Alright folks, sorry, that was a small issue with the stream. Let me do loop back and let's try it again. Okay, Graham, can you say something?
Yeah, I'm here. Can you hear me?
Alright, yeah, now we can hear you. Just 1 second, let me turn on the loop back. Here we go. Alright, I think, 1 second. You should have voice now. Can you say something?
Yeah, I'm here.
Alright, beautiful. And now let me just connect to the Prezo. Again, my sincere apologies for the inconvenience. Let's do this and that. And okay, the stream should be enabled. Alright. You have voice. The streaming has resumed. Again, apologies to everyone.
Thanks. Keep going.
Yep. You can keep going.
Great. So we've been going through each of these services, trying to figure out which ones are important for these flows. They need to be available in order for the user to do these important actions. And when we get to the last one, place on, we see something kind of interesting, which is there's 12 dependencies, but actually only 3 of them are synchronous dependencies. The rest of them are underneath these asynchronous message passes here. What's interesting about this is if we'd used a dependency, a service dependency graph to just show these things, we might have looked at this and gone, oh, there's 12 things here that we need to build resilience into in order to make playing a song a really resilient flow. But actually, by having this extra information in Archium that these links here are asynchronous links, we're able to say, no, we actually only have 3 things here which we really need to focus on in terms of making the system and this flow in particular more resilient. So let me just pop quickly back to the presentation. Hope that doesn't crash everything again. Okay, so what we've been able to do there with Archium is we've been able to browse around the architecture, have a look at some diagrams, have a look at some components and their details. And we're also able to analyze deep dependencies that exist within the system and pull out information about them really quickly. And we're able to get there, what I think is cool, you can get information that no single person in the company knows. When you do microservices, each team ends up with their own little domain, and they might have some understanding of the things around them, but they're not going to understand things in this real depth. So at the moment, Archium is really focused on architecture diagrams and has the beginnings of a service catalog. And the idea is that it's going to be supporting the evolution of a system through automation. So while your system keeps changing, because most of this is automated, you should just be able to upload some new telemetry and everything in Archium about your system will be updated as well. So like I said, Archium is really focused on understanding the system design, and over time it's going to be adding more and more things from that slant, not from understanding the running system, because there's heaps of monitoring tools doing a great job of that, but we're going to be really focused on helping people understand the system design, especially with microservices. So that's all I have to talk about so far. Happy to take questions. If you want to know more about Archium, you can visit the website or feel free to throw me an email at hello@archium.io. And if you want to hear more of my opinions, whether it's because you like them or you want to disagree with them, you can follow me on Twitter. My handle is @evolvable. Yep.
All right, so we do have some questions from our audience. So first, are these component maps automatically generated by trace data?
Good question. So the answer is twofold. Yes, they are generated from trace data. But the other part of the question is that everyone's trace data looks a little bit different. And so there's typically some configuration and customization of the conversion tool in order to make sure that that conversion from telemetry to an architecture model is very accurate and you get exactly what you want. So mostly from tracing data, but you need to configure the tool in order for it to build a good model.
So thank you for the answer. So like another question is that, so do I understand correctly then that developers do not require any like additional proprietary instrumentation to get the flow diagrams as shown in here, or is it mostly a turnkey solution type of thing?
Yeah, so I wouldn't call it turnkey. It does need to be installed, and as I said, in order for that tracing data to turn into a meaningful model, you typically need to customize some things. Some examples of what you might need to customize is depending on what library you're using to send your tracing data to your tracing system. Some of them will send the root of an HTTP request, for example. So it might be like /users /user ID would be the root that you have in your software. But other tools might not send that. They might send the real part. So they might send /users/ and then the actual ID that came in. So 12345, whatever it is. Now, obviously, you don't want to be taking that 12345 and putting that into your architecture model. because that is not your model, that's an individual request. So some of the customization you might like to think about is looking at things like that and saying, okay, well, whenever we see this pattern, we need to actually replace it with the root that we actually want to see in our model. So you need to look through the model that's produced and see what are the things that don't really make sense, and customize the tool a little bit in order to interpret the tracing data. Yeah, that's a good question. So I do have a small tool, which if people want to document their architecture in a little DSL, that can then generate a model that can be put into Archeum. I don't recommend that though, because if you're at the point where you need something like Archeum, where you need to understand your system and hand-drawn diagrams are no longer sufficient, they're falling behind too quickly, or you can't fit the right level of detail in there, then that's where the value really comes from, is taking that telemetry and automatically building a picture, or really thousands of pictures is what's available inside Archeum. Being able to build those thousands of pictures automatically. So if you don't have tracing data, yes, you could use Archeum to document your architecture, but at that point, probably making diagrams yourself in your wiki might still be a solution for you. If you're finding the diagrams in the wiki isn't a solution anymore, probably the first thing you want to do is put tracing on your system, because your system has gotten complex enough that tracing should really be warranted as a high priority.
So what about like one of our viewers is asking that they often find themselves reading through the code once they narrow down the component causing issues. Can Archeum link into a code base to make the jump easier?
Yeah, that's a good question. So I'd love to do that kind of thing over time. As I said, it's all about focusing on understanding the system's design. And yeah, like I say, part of that you can do at a high level by looking at the outside of the component, but sometimes you do need to jump into the code. And so I'd like to be able to enable Archeum to branch off to other things that tell us more about the system. So it could branch off to the tracing for a particular component, or in this case, put a link in there to the source code repository, so that you could go straight from Archeum to finding, the code that you want to look through.
And what about other points of interest for services? So, for example, log data, metrics, providers. Do you have any integrations?
Yeah, there's no integrations at the moment. So a key thing to remember is that there's already lots of monitoring tools. They're doing a really good job of those kind of things. And so Archeum is focused in a slightly different direction of trying to understand the system design rather than the running system. Now, it should be possible to link the two. So from Archeum, it would be great to have it really easy to find the logs or the traces related to a particular component or to a particular flow. That would be great too. In terms of importing that kind of performance data, of monitoring data, into Archeum, that's probably somewhere we won't go, because it's more about it's starting to focus more on understanding the running system. Whereas Archeum's trying to focus on the design while leaving understanding the running system to existing tools that are doing a pretty good job.
All right, thank you. So I think we're done with our list of questions from the audience. If something, I think like you left some like credentials to contact you, if anything. So thank you very much again for your prezo. It's really appreciated, and I hope you have a great rest of the day.
No worries, thanks. Thank you for the questions too.
All right. All right, folks. Thank you very much for joining us today. Only a couple of points before we go off. So we wanted to tell you about other amazing upcoming events that are available online. So first, Serverless Days ANZ is today. Find the information at anz.serverlessdays.io, which is done by the serverless community of Australia and New Zealand. Next, Sydney DevOps Meetup Online is happening on September 17th at meetup.com/DevOpsSydney. And before we completely adjourn, I would like to thank both our speakers, both Neil and Graham, for amazing presentations. And I would love to thank you as our audience, and a huge thanks to a lot of people that are helping me behind the scenes, notably to Jordan, to Rob, and Rich. Thank you so much. And I hope we see you folks next month. The next meetup is already planned, so just take a look at our meetup page. Have a good one.